Okay, this is practice exam number 1, part 2. I did questions 1 through 6 already. Let me pick up at number 7. And number 7 is the one about the car traveling 34 miles per hour. You know what? I've decided that I'm going to cut this one out. There was only one homework problem like this in our homework. It was number 27 in section 1.1, and it wasn't quite as hard as this one, so this is out. It's not on the test. I promise I will not give you one like this on the test. So let's skip it. On to number 8 we go. All right, so number 8 says use Pythagorean Theorem, so they give me a triangle on number 8. Angle theta is there. They have a 10 here. They have a 7 here. They say right angle. Use Pythagorean Theorem first off to find the other side, c. So you remember the Pythagorean Theorem, a squared plus b squared is c squared. So that'd be 10 squared plus 7 squared is c squared. What's that? 100 plus 49 is c squared. 149 is c squared. C is the root of 149. Getting a little scribbly there. So c is the root of 149. Okay, so root 149, that's c. Now what do they want from me? They actually want me to find on this question the secant of theta. Now what's that? Well, it's 1 over the cosine, right? And in a triangle, remember the SOHCAHTOA. So let me write that over here. SOHCAHTOA. So cosine's adjacent over hypotenuse. So this is 1 over adjacent over hypotenuse, because the cosine is adjacent over hypotenuse. Flip this up, high diver upside down kind of thing. It's h over a. So the hypotenuse, root of 149. Whoops, why'd I write 7? Root of 149 over the adjacent. Now what's the adjacent? Well, here's theta, the side across. The opposite is the 7. The adjacent's the 10. The hypotenuse is the root 149. So the adjacent is the 10. There we go, root 149 over 10. Okay, let's move on to number 9. Number 9, it says sine theta is minus root 5 over 3. Cos theta is 2/3. Find the cotan of theta. Well, cotan you can have from your 3x5 card the definitions. It's cosine over sine. So it's 2/3 over minus root 5 over 3. Flip this guy upside down. 2/3 times 3 over minus root 5 cancels out. 2 over minus root 5. Multiply top and bottom by root 5. 2 root 5 over minus 5. That's a negative sign right there if you can't tell. So there we go. Negative 2 root 5 over 5. Looks like option A there. All right, let's go on to number 10. So number 10, they say use a calculator. So they want you to do secant of pi over 5. Now on your calculator, got to make sure that you put that thing in radian mode, because this is a radian angle, right? Oh, and by the way, it's 1 over cosine, right? Remember, secant is 1 over cosine. So use your calculator, check the mode, make sure you're in radian mode, and then do the cosine. So I'm going to do so the way I do is I'm going to do the cosine of pi over 5 on my calculator, get an answer, and, well actually let me correct that. I'm going to go 1 divided by cosine of pi over 5. So 1 divided by cosine, hit the pi button, over 5. I'm getting 1.236, so that rounds to 1.24. Option D. Let's go to number 11. A straight trail with a uniform inclination 16 degrees leads from a lodge at an elevation of 500 feet to a mountain lake at an elevation of 9,700 feet. What is the length of the trail? So it sounds like there's this, I'm talking about a triangle kind of thing. Got a 16 degree inclination, like an incline, going uphill. It goes from a lodge, so here's a lodge, whose elevation is 500 feet, meaning like it's up 500 feet tall. This is, ground level. And to a mountain lake So here's the mountain lake, and that thing is up 9,700 feet tall. So basically, if we take the 9,700 minus the 500, we'll get 9,200. That must be how much this side is. 9,200. Why? Because it goes from a height of 500, right? This is up at a height of 500. This is up at a height of 9,700. Subtract them. 9,200 is the side of that triangle. So it must climb 9,200 feet, right? As you go from here to here, you go from a height of 500 to a height of elevation of 9,700. That means you went up 9,200 feet at your inclination of 16 degrees. What is the length of the trail? So they want x, this trail length that we're on. All right, so what's going to find that x there, that trail length for us? Well, from this angle, I want some kind of trig thing, sine or cosine or tangent, that's going to involve this, and of course the 16-degree angle. What connects those three? Well, this is opposite, and this is hypotenuse. Right? And so that's, so remember the SOHCAHTOA. So what is opposite over hypotenuse? Sine. So the sine of 16 degrees is opposite 9,200 over the hypotenuse, x. All right, so x is what I'm looking for. How do I solve that? So there's my little equation. How do I solve that equation for x now? Well, you multiply both sides of the equal sign by x, cancels over here, and you get x sine 16 degrees is 9,200. Now, bring it over here. X sine 16 degrees is 9,200. How do we finish solving for x now? Divide by the sine of 16 degrees. So, get an answer. Now, make sure your calculator's in degree mode. You got to change back to degree mode now, because we were just in radians. And type that into your calculator. 9,200 divided by sine of 16 degrees. I'm getting, what am I getting? 333.77. What do you want me to round to here? Nearest foot. So I got 0.1, so that's it. 33,377. Yeah, that's option C. The answer is, make that a little neater. The answer is C. All right, good. So there's number 11. It's kind of challenging. Let's go to number 12. So number 12, it's saying find the exact value of the indicated trig. So minus 1/3, 1/2, find the cos of theta. A point on the terminal side of an angle is given, find the exact value of it. Okay, so let's give it a try. So we're saying that we have some kind of an angle, theta, and this point right here at the end of the angle is over a half down. Oh, it's supposed to be down. Technically it would be down here, wouldn't it? Because it would be over. Oh no, I'm getting totally confused. Let's try that again. So it's going to be back a third, up a half, back a third, up a half. There's the angle theta. Because it's x, this is y, right? Back a third, up a half. So I got to find C, the hypotenuse of this triangle. Now you might wonder, for cosine, why can't I just do x? Cosine is only x, just x, when you're in a unit circle, meaning the hypotenuse is 1. But that c is not going to be 1. Let's find c. You know, a squared plus b squared equals c squared. So that's going to be a half squared plus minus a third squared is c squared. A fourth plus a ninth is c squared. So what's that going to be? It's going to be a little bit of work. I'm going to multiply top and bottom here by 9. Top and bottom of this one by 4. I'm going to get 936 plus 436 is c squared. Bring it up here. 1336 is c squared. So C is the root, so you put a root over both sides here, and the root stays on the top. The root of 36 on the bottom is just a plain 6. The root has to stay on the top because you can't root 13. but it roots the 36 in the bottom and vanishes when it becomes a 6. So I've got C, that's the hypotenuse, root 13 over 6. So what now? What's cosine? Well, again, cosine, we can't just say it's x. It's x only when the radius is 1. The hypotenuse, in other words, is 1. So what do? We just do the old SOHCAHTOA definition. What's cosine? Adjacent over hypotenuse. So this angle, which this is the opposite side, this is the adjacent side, and of course this is the hypotenuse. So cosine equals adjacent minus 1/3 over the hypotenuse, root 13 over 6. So flip this guy up, and what are we going to get? We're going to get minus 1/3 times 6 over root 13. This goes into this 2 times, minus 2 over root 13. We can't leave that root 13 on the bottom, so we multiply top and bottom by root 13, minus 2 root 13 over plane 13. There it is, option A on that one. So again, the lesson, the moral of the story is cosine is only just x when you're on a unit circle, meaning when your hypotenuse is 1, but this hypotenuse is not 1. So then you got to do the SOHCAHTOA definition. Or you could say cosine is x over r. In that case, it's x over the hypotenuse. And that's what we ended up doing, right? This was x over the hypotenuse. There we go. All right, let's go to number 13. So 13, they're telling me the cotangent of theta is minus 7/4, and they're saying the cosine of theta is less than 0. And they want me to find the cosecant of theta. Okay, how am I going to do that? Well, let's draw a triangle. Which quadrant is this one in? This one is, remember, it's all students take calculus, so what? Cosine is that's less than 0 means negative, right? And cotangent is negative. Where they're both negative. So we're not in the first quadrant because they're all positive in the first quadrant. We're not in the fourth quadrant because cosine's positive, and yet he's negative wherever we're at. We're not here because tangent's positive here and his upside down cotangent, but cotangent is negative. So we must be in the second quadrant. We're somewhere in the second quadrant where only sine is positive and his upside down cosecant. So right now I know my answer, cosecant, is going to be positive because I'm in the second quadrant where sine and his upside down cosecant are positive. Okay. So with that in mind, let's go there. Let's put our angle theta. And it's telling us what? The cotan is minus 7/4. How do you do cotan? What does that mean? Well, let's remember, cotan is cosine over sine. It's upside down a tangent, right? Which is what? X values over y values. Remember, cosine is x, sine is y, and it's what? Minus 7/4. It says right there. So the x must be minus 7. Kind of running out of room here. Let me bring that down. It's cosine over sine, which means it's x over y, and it's, according to this, minus 7/4. So the x is minus 7, the y is 4. So the x is the y, right? So let's find the hypotenuse C. So a squared plus b squared is c squared. So what do we got? 4 squared plus minus 7 squared is c squared. 16 plus 49 is c squared. What's that? 50, 66, 65 is c squared. Root it. C's the root of 65. So put that over here. Oops. So root of 65. Okay. So now, final question. What's the cosecant? Cosecant of theta is 1 over the sine, right? So how do we do 1 over the sine? Well, what is sine in the triangle? It is going to be, from SOHCAHTOA, sorry, I'm spacing out here, SOHCAHTOA, Sine is opposite over hypotenuse. So opposite over hypotenuse. Flip it up there. It's going to be h over o. So hypotenuse, root 65 over o. Opposite is the opposite from theta is 4. Root 65 over 4. So I'm looking at that answer. I'm thinking that looks like none of the above on that one. Let me double check that that's really the right answer. So that's what, number 13 on part 2. Is that the right answer? Number 13 on part 2. Yep, it's E, none of the above. That's true. It's a weird one. None of the above. All right, let's keep moving. Number 14. 3 more to go. Number 14, they're telling me secant theta equals 9/4, and they're in quadrant number 4. And they want me to what? Find tan of theta. Tan of theta. Okay. So again, we draw a little system. What quadrant are we in? All students take calculus. Secant, which is 1 over cosine, is positive, right? Secant's positive, so cosine's positive. Where's cosine positive? Here. And, oh yeah, it told me, what am I doing? It told me quadrant 4. I don't have to guess. It told me quadrant 4. It wants me to find tangent. What's the sign of tangent in quadrant 4? Tangent must be negative, because only cosine and his upside down secant are positive. All the rest are negative. So tangent's negative. So our answer is going to be negative. We know that right now. Answer is going to be negative something or other. So, what exactly is it? Let's try to find it. So I'm going to draw a triangle in this quadrant. And here we go. A little right angle right there. And angle theta. And the secant of theta, which is 1 over the cosine, is 9. So 1 over the cosine. So if I flip this over, this means if the secant is 9/4, cosine's upside down, so cosine must be 4/9. What is cosine? Remember, SOHCAHTOA. Cosine's adjacent over hypotenuse. So cosine is adjacent 4 over hypotenuse 9. Right, this is the opposite side here. This is the adjacent. This is the hypotenuse. Cosine is 4/9 upside down of secant. So it's 4 over 9. So then I need to find this other side over here. Adjacent, opposite. Call this other side B or X or whatever you want. So A squared plus B squared is C squared. 4 squared plus B squared is 9 squared. 16 plus B squared is 81. Solve for B. Subtract 16. So what's that mean? B squared is something. I don't know. What is 81 minus 16? Use my calculator here. 65. Root it. So B is root 65. So this side over here is root 65. Okay, so getting back to it then. What is the question? What's tangent? Tangent, so SOHCAHTOA. Oh, right? Like that. Opposite over adjacent. So from this angle, opposite over adjacent. Root 65 over 4. For number 14, root 65 over 4. Oh, and remember, we already said it's negative, because really this is down, so it's over 4, down 65. We know it's negative. Why? Because in this quadrant, all students take calculus, only cosine is positive and his upside down. So, I don't want to confuse you, that's a all students take calculus. Anyway, so the answer is actually A, negative root 65 over 4. So watch those signs, whatever quadrant you're in, quadrant 4, just remember that in that quadrant, tangent is negative in that quadrant, because all students take calculus, only cosine and his reciprocal, secant, are positive. Everything else is negative. Tangent's negative. Answer A. So that's number 14. 2 more. Number 15. So minus 13 pi pi over 3. They want me to find a reference angle. What's a reference angle? Well, they want me to find an angle that is a reference angle is between it's 0 to 90 degrees or 0 to pi over 2 radians, right? 90 degrees is pi over 2 radians. So they want me to find a reference angle that's in that zone. I've got to take this. It's going to be the same angle as that. How am I going to do that? Well, first off, you can always add 360. You can always add a bunch of 2 pi's. Because 360 is 2 pi, right? Pi is 180, so 2 times 180, that's 360. So you can add 2 pi. But you got to, that's over 1. You got to get a common denominator to do that. So multiply top and bottom by 3. And then what do we have? Minus 13 pi over 3 plus, what's this, 6 pi over 3. Yeah, that's a fancy 2 pi. That's a fancy 360 degrees, isn't it? Now, if I add 6 pi over 3, I'm still not positive. Let's try it again. Add another 6 pi over 3. That's 12. It's still not there. Add another 6 pi over 3. So that's 18 pi over 3. So this is 18 minus 13 is 5 pi over 3, isn't it? So I made it into a positive angle now, 5 pi over 3. Does that make sense how I did that? 5 pi over 3. Now, stick into the pi 180 degrees, because you want to convert it to a degree. 5 times 180 over 3. Divide that, 60. 5 times 60 is 300. So it's 300 degrees. So let's draw 300 degrees. Where's 300? Well, here's 270. So if I did the unit circle, oops, not a very good one, it'd be right there, 300. It's just 30 off of 270. So how far? So reference angle means to the x-axis. Remember, reference angle is always to the x-axis. How far from here to the x-axis? Must be 60 degrees, right? So that's the reference. The reference equals 60 degrees. But I got to convert that back into radians. What is that? Remember how to convert it? You go times, put the 180 degrees in the bottom, the pi radians in the top, degrees cancel. 60 pi over 180, reduce this, goes in there 3 times, pi over 3. That's answer B. All right, it's number 15. Finally, number 16. All right, the point is on the unit circle, so it's on the unit circle, and they give me the point 5/7 minus 2 root 6/7. They want the cosecant of the angle T. So what's cosecant? Cosecant is 1 over sine, right? So, and sine, now this one is a unit circle. It's a unit circle. So I can just say sine's the y value, x value. So cosecant then, 1 over y, 1 over negative 2 root 6 over 7. That's because that's the y value. Stick it in right there. Take this guy, flip him up, and what do we get? 7 over minus 2 root 6. Right, let's bring that down here. So equals 7 over minus 2 root 6. Got to get rid of that root from the bottom. Multiply top and bottom by root 6. What do we get? 7 root 6 over minus 2 times plane 6. 7 root 6 over 12, and it's negative. 7 root 6 over 12. It's option C. So there we go. There's the entire practice exam. I'll see you on Wednesday for the real exam. Make sure you have a 3x5 card with any notes you want on both sides on that. Again, on this one, unit circle, you can just use sine is y, cosine is x. You don't need to use SOHCAHTOA. SOHCAHTOA would have been okay as well. I could have drawn a triangle and used SOHCAHTOA. But for a unit circle, you can just use y if you want to. If it's not a unit circle, you have to use SOHCAHTOA. You can't just use x for cosine and y for sine. All right, that's all.